Now we're going to move next to our friend Jonah Sandford will take the screen. Jonah, like Ashley, has been working for me and with me since being a student. We've made lots of presentations, Ashley and Jonah and I, at various Society of Biblical Literature meetings together. Jonah has become our specialist on Quire mapping and putting the information that we've accumulated around the mapping of many hundreds of manuscripts into the Beta Mesaheft system. And he's going to give a few-minute presentation here on how he goes about doing that. So, Jonah, you're on.
All right, thanks, Steve. I'm going to go ahead and share my screen. I've just got a few slides. Okay, so yeah, I'm going to try to keep this very short, hopefully sweet. My own very modest contribution to this whole project, inputting metadata into the Beta Mesaheft system, has revolved largely around visualizing Quire architecture for our manuscripts from our catalog entries. So we might start by just taking a look at one of the catalog entries for a manuscript. This is the Heron Codex EMIP 1. And here is our print catalog, what a Quire map will look like in one of those catalogs. And it's a wonderful visual. I love a great visual. And so this sort of thing is very helpful for me. You can see the layout of each quire. You can see the number of folios in each quire, the pagination. You can see when a quire is missing a folio, when there's a stub. There are all sorts of great visual cues here. And this sort of visual representation that Steve and other folks have worked very hard on is wonderful. But what if we could do a little bit more with those visuals? What if we could place them in an environment that allowed linking of image sets, that allowed accessibility to be widened so that these visuals could be accessed by many, many more people with relative ease? What if we could place them in an environment where data could be taken from these visuals and be quantified? All sorts of sophisticated things can happen once we take this data from a print catalog and digitize it. And so that's what I've been working on in the Beta Mesaheft system to get some of this information on there. And so the first step of that is just pushing the data to the website so those visuals are there. So I'm going to describe in just a couple of minutes how I do that. And I do that by taking an XML file of the manuscript. So this is the XML view of the Heron Codex. And I use a text editor, Atom, to write code that basically converts that metadata, converts that visual to a string of code that I can then put on the Beta Mesaheft system and visualize those Quire maps there and do a couple of interesting things as I do so. So for each manuscript, there's kind of a base sort of skeletal structure that allows me to input certain values to visualize certain things. So Quire numeration, Quire pagination, so folio range. I can also do neat things like include notes for interesting information, like maybe in one quire, for instance, in Quire 22 in this manuscript, we have a folio that's cut off halfway between the gutter and the margin. I can include a note with that, and I can include a locus statement that tells me what folio that is. I can use a fact statement to link an image to that folio. And so right away, we're integrating this visual that we had in our print catalog with image sets that Ashley and other folks have worked really hard to integrate into the system. And so basically, I turn all of this into code. I push it through GitHub into the Beta Mesaheft system. And then we end up with this great visualization that corresponds to what we were seeing in the catalog. And so just in a couple minutes, I'm going to take us to Beta Mesaheft to show one or two of the things that are possible once we have that visual up there.
And we will need to keep track on the time here, Jonah. You're doing great. Yeah. This is good, but great.
Great. So once I push this to Beta Mesaheft, this is what I end up with. This section where we're looking at the Quire structure, we see some of the notes I've placed in there. And the most exciting part of this for me is we can open up the Quire diagrams, and we see that we have all of a sudden all of these expandable visuals where I can open these up and I can see the structure of each Quire. This looks somewhat like the catalog entry, but now it's more widely available. It's aggregatable, it's quantifiable. All of these interesting things can be done. And just as one final note, we can look back at Quire 22 here, and we see we can even visualize when a folio is missing, when there's a stub. And then beyond that, because Ashley and Steve and others have done the legwork to upload image sets into Beta Mesaheft, I can link to those particular images. You want to see what exactly that looks like for that stub to be missing. We can link to that image. And now we can see here, here's our folio stub. And there's the note I mentioned previously about the folio that had been cut off halfway between the gutter and the margin. And so this is one capability that we have when we start taking all of this metadata and putting it into our system.
Yeah. Jonah, thank you so much. If you stop sharing there, and really appreciate your work. You gave us a glimpse into the XML world, and for those of you that don't have an introduction to XML and what it is, to really understand the foundation of the coming generation, it's hard to say you have a clear picture of that if you don't understand what XML is and what it gives you the capability of doing. It takes a huge amount of work on the front end for people like Jonah and others to tag up all the details in your metadata with XML tags. It's just mind-numbing work, and it goes on for years. Nevertheless, when that work is done, what it increases is the capacity on the researcher's part to aggregate, bring together stuff digitally in ways that the individual researcher is never going to be able to accomplish. So there's understanding why XML is foundational to the future of things, and then understanding the design of the Beta Mesaheft system, for instance, which is grounded on XML. You can't appreciate why that system stands out from others in the way that it does until you understand what's behind this whole business. So thanks for that glimpse, Jonah. We're going to move now. I would love for us to spend a while on Transkribus and the work that's done there. Is Abba Daniel here with us this morning? Have I seen him yet? Abba Daniel, are you there? With textual, many people are using manuscripts, obviously, for textual research. And to look at pictures and see text is one thing, but in a digital age, you've got to get those keystrokes captured. You've got to get the thing, get the characters either typed up or these days using optical character recognition tools to do that. And we could spend quite a bit of time. We're not going to take the time this morning. Actually, Abba-Daniel Asafa has been working now with me and with teams of people in Addis. There's a team of 6 workers who do transcriptions of manuscripts. And we have done so much work together in the THEOT project. Textual History of the Ethiopic Old Testament requires that we identify 30 copies of a book of the Ethiopic Old Testament, transcribe all 30 of those copies, and do it perfectly, or as perfectly as we can. So we go through a 3-step process, a point 1, a point 2, a point 3, 2 independent transcribers, and then you compare their work, and where they have differences, you compare it against the images. It enables us to get accuracy rates of well in excess of 99% accuracy. Abba-Daniel is a team member of the THEOT project and directs the work of the team of transcribers in Addis. And it's been really fun to watch the development of that team. We have statistics on all of their individual performance, what their error rates are, and they've been a wonderful workforce that are working very diligently these days to do this work. I'd hope that Abba-Daniel would be here to tell you a bit about that. I'm sorry to say that he's not. The next 2 things then, the counterpart to the physical typing, transcribing of manuscripts then, is optical character recognition using this new tool that's become available called Transkribus. I'm going to share my screen again, and we're going to watch a video that Ralph Lee has made.
I'd like to introduce you to the wonderful world of Transkribus. Here I'm on the Transkribus website, which announces it as this comprehensive platform for digitization, AI-powered text recognition, transcription, and searching of historical documents. Transkribus software is free, and when you sign up for a Transkribus account, you get 500 images processed for free. And after that, you can buy extra credits to process work at a very reasonable price. Once you've downloaded the software, it's possible to upload images and do various tasks to process images, to work out where text is on a page, and then to read the text and transcribe it. You can see on this page that that has all been done. This is a short commentary on Enoch from the Gundagundi library that I'm working on at the moment. And as you can see, the image has been marked out with columns in these green boxes, lines, and underneath is transcribed text. And this is text that Transkribus itself has read. The process itself is quite simple. So here we have a manuscript that I haven't, or an image that I haven't yet processed. Various simple stages. The first one is to allow Transkribus itself to work out where it thinks text is on the page. If I run this very quickly, it will ask me if I want to do it, do a double check. It will take a few seconds to then come back with a message. Taking a few, there we go. If I say yes, reload the page, and as you can see, it's worked out pretty well the lines that are marked here and the text areas. You can edit this if you go to this layout page. Any particular bit of text can be edited. You can extend it, you can cut it up into pieces, or do various other things to do with it, including changing the reading order if that's necessary. But in this case, I'm not going to do much more. The next stage of using Transkribus is to choose a model. Transkribus works for many different languages, but if you're reading Ethiopian manuscripts, what you need is this one, which is produced by the team at Hamburg, led by Pietro Liuzzo, who's been working on this for some time. Then I can ask Transkribus to have a go at transcribing the text and producing an image. So I can tell it to do that. Just do the current page. Tell it OK. It does a double check. And again, it will take a few seconds to work out its reading of the text. The accuracy is reasonably high. It can end up in the high 90s depending on the quality of the manuscript. And particularly with poorer quality images, how well you've worked at getting the areas of text defined well. But with a clear image like this, that's usually done very well automatically. Here we go. Here we are, and here underneath is the transcribed text. You can see it's had a little bit of difficulty up here with the damaged part of the manuscript, but down below you can see that it's done a very good job at reading this text quite accurately. I can now edit this text, and it's possible to export it either in XML files that can be processed to use for transcriptions on Beta Mesaheft, or you can export it as a Word document and in various formats. So the possibilities are quite extensive, and I strongly recommend that you have a go at using this software. I'd like to introduce you briefly to the process of taking data from a printed manuscript, or indeed any other data that's been recorded on a manuscript, and turning it into an entry on the Beta Mesaheft website and all the enhancement that comes with that. As you can see here, I've got a Word version of a catalogue for the Ethiopian Manuscripts Imaging Project. We're going to take a look at a Psalter. The recorded information includes dimensions, folios, major works, miniatures, extra works that are added after the initial completion of the manuscript, and any other information, scribbles and notes that are put on the manuscript, and a Quire map. This information can be entered easily into using an XML editor to produce on the Beta Mesaheft website a page like this, which includes details of contents, additions, extras, decorations, and various things, and various other information here about the Quire construction. The layout information is all here. Issues related to the hand, in this case, notes about the rubrication and where works are rubricated. The process is relatively simple. It takes a little bit of working out, but through either something like the Atom, or in this case the Oxygen XML editor, we can edit a file and enter all the contents that are necessary. Some of these lines of code look a little confusing, but most of this data is generated when the file itself is generated on the Beta Mesaheft system. The focus for coding is on entering contents. So in this case, we have the contents. This work is a Psalter. So we've got an overall record here with its code that's available in the Beta Mesaheft CLAVIS. And then nested within it, we've got Psalms, Song of Songs, Wodasi Mariam, and even nested within that, the breaking down of the work of the Wodasi Mariam to readings for different days of the week. Beyond that, we've got physical descriptions, the dimensions, and various other components. Information about the Quire construction. And then other information here about number of columns. Here's the code about the rubrication under hand description, and anything about the hand can be entered there. Decorations, here miniatures, some of which have standard entries like here for the crucifixion. The decorative designs, lines of dots that are in colours, and various other features that are common in Ethiopian manuscripts. And then our additions and extras. Things marked with an A are more significant additions, and things marked with an E are either blank pages, scribbles, or other minor additions. And here the information about the date. The editors are quite sophisticated, so for instance they can allow us to check the content. So if I look at this line of code here, I ask it to show me the attributes, it produces me a form in which I can enter the data and make sure I enter the code correctly. In this case it's just a fact statement. This fact statement tells it what image to take to correspond to, in this case, folio 1R and a folio range. Furthermore, the editor validates the code to make sure it will compile correctly. And then through GitHub there's a process to further validate files and have them checked by the team in Hamburg and be merged with the data on the website to produce this. So if we take a look at some of the features, here you can see the nested information. It's telling me there are 6 works in here under the Ethiopian Psalter. Here we've got the Psalms, the Canticles, Song of Songs, etc., all listed. And under their entries, a title, a CLAVIS entry. And in this case, if I click on the folio range, I get an image. And indeed, it takes me to the image where that particular work starts. And I can scroll through there and look at the subsequent pages as well. Same very much with other things. If I wanted to look, for instance, about the details of this transaction note, I can click on there, and here you are. I'm at the right image. All has to be obviously done, coded correctly for it to work properly. Finally, if I wanted to look at, for instance, this image of the crucifixion, I can click on here, and there is the image. So if I wanted to look at artworks, I could do that. The system is still under construction. There's a very helpful set of guidelines that have been produced by the Hamburg team. So most coding questions can be worked out using that. But if not, there's an extremely helpful and enthusiastic team in Hamburg to help you code things up. The fact that these works are recorded through the CLAVIS does mean, for instance, that I can click on the work itself, in this case the Song of Songs, and I can find information about the work itself, and if the system will respond in time for me, I can also then find other entries on the Beta Mesaheft system that have got that content. That's a bit slow for me just now, so I'm not going to do that just now. And finally, if there's Quire information and that's been entered correctly, I can use the Quire maps to show me the simple structure of the quires, where they start and where they finish. In this particular work, the quires are mostly simple, but here we've got a more complicated one, which has got stubs and so on that have been entered in the coding. There's a lot more to do. As you can see from the details up here, we can have transcriptions added, and we've talked about that, and we will do in relation to Transkribus and how those entries can be included. We can also look at the images in another way through the image viewer, which allows us to look through in a more conventional way with a set of images that are not going to respond for me. Here they are here, and I can then also find catalogued items by clicking on these notes at the side. And I can click through the image set in this way to find any image that I wish to do so. Hope that's helpful, and we can always help somebody or anybody interested in getting going on this with some guidance and some assistance.
We're going to move now to the next step in the process. Garry Jost is going to make a presentation because we come to the step of converting texts now into statistics. If we're going to do computational analysis as we do in the textual history of the Ethiopic Old Testament project, we need a set of algorithms and tools using computer capabilities to do this work. Garry, thank you. You're on.
Welcome everyone, and thanks for joining today. An exciting part of our research has been using computers to do some of the analysis, and it's been a combination of manual processes and computer processes. And often they fed off each other and one encouraged the other. We'd have a manual process and I'd say, hey, I think I can automate that. And so then I'd write a computer script for that. And then once people saw the computer script, they'd say, oh, well, that sparks in my mind another manual process we can do. Jeremy Brown was especially good at this, kind of the next step. And after that, then I'd, if I could, write a computer script for that. And so that's been, I think, a wonderful part of our research. So I am now going to share. So using computer scripts, and script is another name for a program, computer program, converting these text to statistics. I'll talk about that. And then also I created a website we call the THEOT text viewer that helps us really see in an important way the different readings of the different manuscripts. What you see at the top is something that we do by hand, a manual process. And so we take all the readings of all the manuscripts and put them together. Here you see only 6 manuscripts. We normally use at least 30. And then we line things up by hand, by spaces and tabs and a dot in the case of a missing word. And the top part is done by hand. A computer program converts it to what you see at the bottom. And the 1s and 2s represent, if it sees a word up above, it puts a 2 down at the bottom. If a word is missing, it puts a 1 there. Once we have that, the 1s and 2s, we can calculate a percentage agreement. And so if you compare witness 3 with witness 6, you could do this by hand, compare each one. Is it the same? Count how many are the same and what's the total number, and divide to get a percentage agreement. Of course, you can have 1,000 or several thousand rows, and it's really ideal to have a computer do that. Once they do that processing, then it goes in another table, another sheet. It's actually Google Sheets we use, where it records that percentage. We use Google Apps Script, and the wonderful thing about that, on a Google Sheet, you can introduce a new menu. And so I click that, that opens a menu here into a submenu, and eventually then you click that and the computer script is run. I'm going to actually go to a demo of that. So this is a Google Sheet. Some of you have worked in Google Sheets just for recording data, but programmatically you can add in a menu here, and then a sub menu, as I mentioned. And in some cases, like for distinctive readings, it's possible to do a simple dialogue. So you create a dialogue where the user inputs some information and then eventually clicks submit, and that kicks off the process. A few interesting things. I've worked on StemmaWeb by Tara Andrews. I set up some data and uploaded that to her site. She sent out email recently to all the people who have done that she's revivified her site. Orthographic study, and now for the NEH project we have worked on some SQL scripts for that. Once you have the percentage agreement, additional computer scripts do some processing and then feeds this data to our statistical package. Some of you may be familiar with that. A lot of universities use that. And what that generates is a dendrogram that you see here, the relationships of all the manuscripts. And you can see, for example, on the left, 2 manuscripts are closely related and not closely related to all the other manuscripts. The reason for this is that we determined they were translated from Latin. The books on the 2 manuscripts on the right are closely related, and they're more closely related to those manuscripts close to them than the ones further away. I'll pause at this point. So we do statistical analysis and believe it is a very important part of what we do. But that's just part of the analysis. Eventually, we require philological analysis and textual criticism. Some of the techniques of that and practices for actually determining, the genealogical relationship. That leads into the next point. A dendrogram is not a stemma. Okay, so we want to make that clear. Stemma shows genealogical relationship. A dendrogram shows how closely the manuscripts are related, and specifically in terms of what we are measuring. We take the dendrogram and then with some additional information, identify clusters. This leads us to identifying text types, such as what we believe to be the earliest attested, and then a standardized form. And so this then is part of the additional analysis. What's really cool about this is once you have this database and computer processing, your additional things you can do is practically unlimited. And so some of the things we have done is a script to identify distinctive or unique readings of a cluster. If you have a cluster and 100% of the manuscripts of that cluster have a reading, but that reading is not found anywhere else, well, that's a unique reading. Best representative manuscript, we programmatically determine a cluster profile and then can compare against the various manuscripts in that cluster to use that perhaps for a diplomatic version. Orthographic analysis with Jared Jacob, I did that, and various other things. And whatever can be thought up possibly can be programmed. One thing I'll mention, we think it's important, distinctive readings, we can identify these with precision. The computer script points us right to certain readings. And so for an example, if 100% of the manuscripts in cluster 1 have a reading and only 10% of the manuscripts in the other clusters, then you do some simple math and you get 90%. And so the higher the value, of course, if it's 100%, that's a unique reading. And that is important for understanding possibly transmission history and the textual history of these manuscripts. This precision I will contrast with this. And so this is from Bart Ehrman, where he is criticizing some, not all, but some of work in textual criticism by being imprecise. So it's attested mainly in witnesses of one group. It's attested by most group members. Well, is that 90%? Is that 51%? Or attested only by a few? The last one attested by at least 2/3, that is somewhat more precise. But we believe that it's important for this precise identification of how distinct is it, whether it's unique or a high level of distinction. We've used Google Apps Script with Google Sheets. We're moving toward what we might call a proper website with a proper database. Google Apps Script absolutely was the correct decision at the time. It was free of charge and it was very convenient. The deployment model is super. You don't have to install software on laptops, but it does have limitations. Using Google Sheets as a database, it's not great. I remember one of the presentations I gave in Europe, in the question and answer, someone asked, well, why don't you use a real database, Google Sheets? And that's a totally valid point. Yeah, it's simply not ideal. It has worked for us, but we're moving away from that. There's a 6-minute time limit on scripts, and so that meant it's splitting it up into a lot of scripts. With the NEH grant that our project has received recently, we'll move toward a proper SQL database and a better user experience. I'll move now to the next topic, the THEOT text viewer. Actually give a demo here.
And just a couple minutes, Gary. I'm sorry to press, but we're moving along with our time.
Okay, excellent. So I'll open up a new one here. All right, so the UI isn't great. That's not where I've given my attention. We have a bunch of manuscripts here. So you can select a manuscript. Experimentally, we did a little bit in Coptic, only one verse, and experimentally did a little bit in Arabic. But I'll leave this set on Deuteronomy, click display. And so here you see the text of Deuteronomy. And what's most important, this setting, all manuscripts by cluster, with it set to that, I can click here. And what we have, it's laid out according to cluster. These are our cluster names, earliest attested 1, earliest attested 2, transitional A. And then you can see them all laid out, and it's a wonderful way to access them and understand what's going on. For instance, this word "kama" here, you see, well, in this first cluster, all of the manuscripts have that, but it is not in most of the other manuscripts. And so you can get a quick look at that. Here we have kind of the great divide. The manuscripts above, the earlier manuscripts, are quite different from the manuscripts below, the later manuscripts. And one cool thing I'll show you, if I copy this word, and up here in the database section, we're going to search Dillman out on the Beta Mesaheft site. And so if I click OK, in a few seconds, mere seconds, it goes to Hamburg and back and retrieves this information that has been entered by the Hamburg team. And so that can give some pretty cool information for the researcher. I do have some proper acknowledgements here for what I just did. And I believe with that, we'll go back here, and thank you very much. That's my presentation.
What you've seen here is the counterpart to XML in a certain kind of a way, taking textual information and converting it to numbers before we can start to use computers on it. And to get your mind around how that works and what it does, it's hard to overestimate the worlds of opportunities that come available when when you're able to look for minute patterns amongst thousands of readings in a bunch of manuscripts, and it takes this sort of computer tool to be able to do it. Thank you so much, Garry.
Thanks, Steve.
Thank you.